Good morning. Today our topic is magnetic dipole moment of a revolving electron. See, magnetic dipole moment. Magnetic dipole moment of a revolving electron. This is an important one, important topic also. You know well, the electron should revolve around the nucleus. Just imagine the electron should revolve in circular path. This is nucleus, electron. The mass of electron is m. The charge of electron is E. Velocity of electron is v. The electron should revolve around the nucleus in velocity of v. The electron should take, just imagine it is circular path. The radius of circular path is r. This is also a circular path. See, the velocity of electron is v is divided in two components. Get that v sin theta. The angle between r and v is 90 degree. I want to calculate this magnetic dipole moment of revolving electron. You know well the before class, magnetic dipole in a circular loop, magnetic dipole mu vector is equal to I into A vector. A circular loop. See, the revolving electron should act as revolving electron around the nucleus should act as circular loop. Almost like this circular loop. You know well the magnetic dipole moment of circular loop mu vector is equal to I into A vector. This is equation number 1. I want to calculate this magnetic dipole moment of revolving electron. See, you know well, this is I, current. You know, current is a scalar quantity. This is area vector. Mu is a dipole moment of circular loop. So the electron revolving around the nucleus acts as a circular loop. That's why we take this equation mu vector is equal to I A vector. I want to calculate this I. What is I? The flow of current. Define current. The rate of flow of charge is called as electric current in a particular cross section. It is a very important. I is equal to minus E divided by T. The rate of flow of charge is called as electric current. The negative sign is indicates the flow of charge. The electric direction of electric current is opposite to the direction of electric charge. The electron should revolve in this direction anti-clockwise, but the current direction is clockwise. The negative sign almost indicates this. The negative sign, the charge of electron are symbol. The directions of flow of charges or direction flow of electron. Direction of current. So I is equal to minus E divided by T. The rate of flow of charge is called as electric current. Who is T? The revolving time period. What is speed of electron is equal to velocity of electron is equal to V is equal to total distance divided by time. Distance divided by time. So V is equal to total distance. Just imagine this is a circular path. So one complete revolvation almost equal to circumference. So circumference is equal to 2 pi r. 2 pi r. So the distance is equal to 2 pi r. The time period is T. So T is equal to 2 pi r divided by V. This is a time period, revolving time period. What is electric current? I is equal to minus E divided by T. In magnitude, I is equal to E divided by T, which is equal to E into F. So 1 divided by T, reciprocal of time is nothing but it is a frequency. Another one equation, I is equal to E into F, but the angular velocity omega is equal to 2 pi F. F is equal to omega divided by 2 pi. So F replaced. omega divided by 2 pi. This are current equations. I is equal to E by T, or I is equal to EF, or I is equal to E omega divided by 2 pi. This is current equations. This is equation number 1. Sorry, this is equation number 1. This is equation number 2. This is equation number 3. T is equal to 2 pi R divided by V. In equation 3, time period substitute in equation number 2. Get I is equal to E divided by T. So I is equal to E divided by, what is the T value? T is equal to 2 pi R divided by V. 2 pi R divided by V. So I is equal to, goes to EV divided by 2 pi R. This is a current equation. I mean the equation number 4. So current value I is equal to EV divided by 2 pi R. The flow of electric current produced, the flow of electric charges should develop the current is equal to EV divided by 2 pi R. I want to calculate this dipole moment of revolving electron. Dipole moment of revolving electron. See dipole moment equation. So mu L, I want to take in convenient mu L. So mu L vector is equal to I A vector. In magnitude, mu L is equal to I A. So you will define I value. I is equal to EV divided by 2 pi R. A is the area of circular path. So area value is 2 pi R square. Sorry, area of circular is equal to pi R square. I is equal to EV divided by 2 pi R. So now mu L equal to I into A. So mu L is equal to, what is I value? EV divided by 2 pi R. EV divided by 2 pi R into A, area of circular path, pi R square. So R value square cancel. So pi value cancel. So remaining mu L is equal to E V R divided by 2. This is the dipole moment of revolving electron, EVR divided by 2. Another one is very important. Mu L is a dipole moment in vector quantity. I want to measure the directions. So you know well in circular loop direction before class, the charge direction is this direction. I mean anti-clockwise direction. The current direction is opposite to the direction of flow of electric charge. So this is current direction. You know well the right thumb rule. See the finger curl is indicate current direction. The thumb points the direction of magnetic moment direction. So this is current direction. So current, I mean magnetic dipole moment direction is downwards. This is downward direction, mu L. This is current direction. This is dipole moment direction. This is current direction. So the finger curl indicate current direction. The thumb points the direction of dipole moment. So this is downward direction. Mu L in downward direction, which means mu L is equal to EVR divided by 2. It's a very important. This is equation number 5. Another one, I want to calculate this momentum, angular momentum. What is angular momentum? Angular momentum, which is equal to L is equal to L vector is equal to R into P vector. This is a linear momentum, radius, angular momentum. The relation between linear momentum and angular momentum, L vector is equal to R P vector. So this is 90 degree. V and R is 90 degree. Divide and V sin theta component, you know well. So P value is equal to, P is equal to mass into velocity, velocity component V sin theta. So substitute this. L vector is equal to R into P vector is equal to mv sin theta. The angle between R and V is 90 degrees. So sin 90 is 1. So L vector is equal to R mv, which means L is equal to mvr. So L is equal to mvr. Equation number 6. L is nothing but this is angular momentum. Angular momentum which is equal to mvr. Mass of electron, velocity of electron, radius of circular path. Equation number 6. Angular momentum. So this is magnetic dipole moment of revolving electron, EVR divided by 2. This is angular momentum of electron. L is equal to mvr. So L is equal to mvr and mu L is equal to evr divided by 2. Equation number 5 divided by equation number 6. This is mu L divided by L is equal to evr divided by 2 whole divided by mvr. So which is equal to evr divided by 2 into 1 divided by mvr. So r, v cancel. Mu L divided by L is equal to E divided by 2m. This is very important equation. This is called as Gyromagnetic Ratio. Mu L divided by L, which is equal to E divided by 2m, or mu L divided by L is equal to E by m whole divided by 2. E by m is nothing but this is specific charge of electron. We will see and discuss about specific charge, atomic physics, unit 8. Mu L divided by L is equal to Em divided by 2, half of the specific charge. Specific charge value is equal to 1.7 into 10 power 11 coulomb per kilogram. See, I want to calculate this E divided by 2m. E is the charge of electron, m is the mass of electron. Here, mu L divided by L is equal to E divided by 2m, which is equal to 0.0878 into 10 power 12 coulomb per kilogram. So, mu L divided by L is equal to E divided by 2m, which is equal to 8.78 into 10 power 10 coulomb per kilogram. See, E is the charge of electron. Mu L divided by L is equal to E, charge of electron. What is the charge of electron? 1.6 into 10 power minus 19 divided by 2 into mass of electron 9.11 into 10 power minus 31 kilogram. It is equal to, finally we get 8.78 into 10 power 10 charge divided by mass. So coulomb per kilogram. So mu L by L is nothing but which is equal to E divided by 2m, which is equal to 8.78 into 10 power 10 coulomb per kilogram. This is called as gyromagnetic ratio, or half of the specific charge. Gyromagnetic ratio mu L by L or E divided by 2m called as gyromagnetic ratio. It is a very important equation and important constant, which means, listen, mu L is a dipole moment of revolving electron. L is the angular momentum. So dipole moment angular momentum ratio, which is equal to constant. Here mu L divided by L is equal to constant, which is equal to E divided by 2m. So mu L divided by L equal to, mu L is equal to constant into L. So L is the angular momentum. This is dipole moment of revolving electron. The dipole moment revolving electron depends on L value. L is the angular momentum, is directly proportional to angular momentum. If L value increases, mu L value is also increases, directly proportional. If L value decreases, mu L value is also decreases, directly proportional. This constant is nothing but just equal to E divided by 2m. See, mu L divided by L, mu L divided by L is equal to E divided by 2m. E is equal to 1.6 into 10 power minus 19 divided by 2 into mass of electron 9.1 into 10 power minus 31 kilogram. We get final answer 8.78 into 10 power 10 coulomb per kilogram. This is a constant. Mu L divided by L is equal to E divided by m is equal to constant value. So mu L is directly proportional to L. Angular dipole moment is directly proportional to angular momentum. So angular momentum increases, dipole moment is also increases. L value decreases, mu L value is also decreases. So mu L is equal to constant into L. The constant is nothing but this is E divided by 2m. This is called as gyromagnetic ratio. Gyromagnetic ratio. Mu L is equal to 2 E divided by 2m into L. It is a very very important equation in this section. So next one is mu L is equal to E divided by 2m into L. This is angular momentum. According to Bohr quantization theory, in atomic physics you deal in detail Bohr magnetic quantization theory, angular momentum L is equal to n times of h divided by 2 pi. N is nothing but it is a constant circular, which means a circular orbit. So L is equal to orbit, number of orbit, first orbit, second and third orbit, which is equal to angular momentum L is equal to n h bar. H bar is nothing but h divided by 2 pi. This is quantization theory. You will detailedly explained in the Bohr atom model in the atomic physics. L is equal to n into h divided by 2 pi. H is nothing but this is a Planck's constant. This is Planck's constant. The value of Planck's constant is equal to h is equal to 6.63 into 10 power minus 34 joule second. Angular momentum of revolving electron, the angular momentum of revolving electron, which is equal to n times of h divided by 2 pi. This is a Bohr quantization theory. So L is equal to nh divided by 2 pi. So h is a Planck's constant. This equation substitute in here. Mu L is equal to E divided by 2m into L is equal to nh divided by 2 pi. So mu L is equal to, this is n E h divided by 2 into 2, 4 pi m. This is constant. So mu L, magnetic dipole moment of revolving electron. N is the number of orbit. If first orbit n equal to 1, if second orbit n is equal to 2, third orbit n is equal to 3. So mu L is equal to dipole moment of revolving electron in first orbit or now n number of orbits, which means n is the number of orbits. It's very important. Mu L is equal to n E h divided by 4 pi m. E is the charge of electron, h is a Planck's constant, and pi constant, m mass of electron is also constant. So mu L is equal to n into E charge 1.6 into 10 power minus 19 coulomb into h Planck's constant 6.63 into 10 power minus 34 divided by 4 into pi value 3.14 into mass of electron 9.1 into 10 power minus 31. We get final value L is equal to 9.27 n value. So n into 9.27 into 10 power minus 24 ampere meter square. This is a magnetic dipole moment of revolving electron. If first orbit n equal to 1. What is the least magnetic dipole moment of an electron if n is equal to 1? What happens? Mu L, which is equal to mu B. Mu B is the least value of magnetic dipole moment of revolving electron, which is equal to n equal to 1. So 9.27 into 10 power minus 24 ampere meter square. This is a magnetic dipole moment of revolving electron. Another one is very important. In our textbook, mu L is equal to minus E divided by 2m into L. It's a negative sign. It's very important. What is a negative sign? The negative sign indicates direction of mu L or direction of L. It is a very, here L is also vector quantity, mu L is also vector quantity. The negative sign indicates mu L value is opposite to the direction of L value. Dipole moment, this is angular momentum. Angular momentum opposite the direction of dipole moment, or dipole moment is opposite the direction of angular momentum. See, this is flow of charge in circular path in anti-clockwise direction. What is current direction? Current direction is opposite to the direction of flow of charge. So this is current direction. You know well thumb rule in a circular coil loop. See, consider this is a circular coil loop. This is current direction. This is mu L. See, another one. What is angular momentum direction? You know well the angular momentum direction, screw rule. See, This is momentum direction. V, I mean the V direction almost equal to P momentum. I want to calculate this angular momentum direction. Angular momentum direction. Just you rotate in screw in anti-clockwise direction. You apply the velocity of screw is in this direction, anti-clockwise, but the screw in upward direction. Movement of screw is upward direction. So the moment direction, angular momentum is this direction, upward L. See, if screw rotated in clockwise direction, moment of screw is inwards. If the screw rotates, just imagine this is screw. The screw rotates in anti-clockwise direction. The screw in outward direction, move in outward direction. This is direction of angular momentum. So here mu L is downward direction. In your textbook, the mu L in downward direction, L is upward direction. Say the mu L direction is opposite to the direction of L, or L is opposite to the direction of mu L. The negative sign indicates the dipole moment value is opposite to the direction of angular momentum. So mu L is equal to minus E divided by 2m into L. Finally, you get the value mu L, least magnetic dipole moment of revolving electron. Mu L is equal to, the least value is 9.27 into 10 power minus 24 ampere meter square. Mu L divided by L is equal to NEH divided by 4, mu L is equal to NEH divided by 4 pi m. Least value N is equal to 1. So mu L is equal to N equal to 1 into E is equal to 1.6 into 10 power minus 19. H is equal to Planck's constant 6.63 into 10 power minus 34 divided by 4 into 3.14 into mass of electron 9.1 into 10 power minus 31. We get final answer mu L is equal to N value is 1. So 9.27 into 10 power minus 24 ampere meter square. This is the least value dipole moment of revolving electron. Mu L is equal to N equal to 1. So that is equal to mu B 9.27 into 10 power minus 24 ampere meter square. See, mu L is equal to NEH divided by 4 pi m. Here N equal to 1. Mu L is equal to EH divided by 4 pi m, which is equal to 9.27 into 10 power minus 24 ampere meter square. This is called as Bohr Magnetron. The name of mu L is equal to least magnetic dipole moment of revolving electron. Mu L is equal to EH divided by 4 pi m, which is equal to 9.27 into 10 power minus 24 ampere meter square. This is called Bohr Magnetron. Bohr Magnetron. Another one result in the topic, before class, Gyromagnetic Ratio of the specific charge. See, mu L is equal to EH divided by 4 pi m is nothing but this is a gyromagnetic ratio. The value is 9.27 into minus 24 ampere meter square. Magnetic dipole moment of revolving electron in least dipole moment is equal to EH divided by 4 pi m. Here N equal to 1. This is called as Bohr Magnetron. Next is the Ampere Circular Law. Ampere Circular Law is nothing but the line integral of magnetic field closed surface is equal to mu naught times of net current in closed loop. This is a Ampere Circular Law. This is almost like this Gauss law in electrostatics. In electric field we are using Gauss law. In magnetic field we are using almost Ampere Circular Law. Same phenomena. This is independent of shape of the path and position of the conductor. Same, Gauss law is independent of the shape of the path and position of the charge. Same like this in magnetic field, Ampere Circular Law is independent of, does not depend upon the shape of the path and position of the conductor. Ampere Circular Law is nothing but the closed surface integral of, this is closed surface integral of magnetic field, which is equal to mu naught times of net current, in enclosed loop. So closed surface integral B vector dot dl vector is equal to mu naught times of net current in enclosed loop. So I enclosed loop. This is Ampere Circular Law. Next is a magnetic field due to the current carrying wire of infinite length using Ampere's law. See, just consider the infinite wire, infinite length. consider the flow of current is I. You know, well, the current flows through the current carrying conductor, the magnetic field, the magnetic lines of developed around the conductor. This is a magnetic lines, magnetic field. Just I want to take this in small element. This is dB. This is the circular of magnetic lines of force. Radius is R. R radius. The magnetic field should develop around the conductor. Flow of current is I. A small element is dB. I want to calculate small element magnetic field due to the current carrying wire, using Ampere Circular Law. Closed surface integral B vector dot dl vector is equal to mu naught times of net current. Ampere Circular Law. In this, each and every element, the magnetic field is same. So overall magnetic field is B is constant. So closed surface integral of dl vector is equal to mu naught I, mu naught times of net current. I want to calculate this at dl. Dl is the overall circular length, the circular path. The circular path is almost equal to circumference. Here, B closed surface integral dl is equal to mu naught times of I. See another one, B vector dl and B vector dot dl in magnitude closed surface integral B dl cos theta is equal to mu naught times I. Here cos theta is a very important one. The theta is the angle between small element and magnetic field. The small element along the direction of magnetic field. So this is almost parallel. So theta value is 0. Closed surface integral B dl is equal to mu naught times I. So here field is constant for every element. So the magnetic field is constant. Closed surface integral dl, which is equal to mu naught I. So B into closed surface is equal to L into mu naught I. This is length of the circular path is equal to circumference. So B into 2 pi R is equal to mu naught times of net current. I want to calculate this magnetic field. B is equal to mu naught I divided by 2 pi R. So this is a magnetic field due to the current carrying wire of infinite length using Ampere's law. So B is equal to mu naught I divided by 2 pi R. Another one. Here closed surface integral B dl cos theta is equal to mu naught I. The theta is nothing but the angle between current element and magnetic field. The current element and magnetic field is the same direction. So the theta value is 0. The angle between magnetic field and current element is 0. So closed surface integral B dl cos 0 value is 1, which is equal to mu naught I. So field is constant for every point on the circular path. So B dl closed surface integral dl is equal to mu naught I. So B into dl closed surface integral dl overall this is circular length. This is equal to 2 pi R is equal to mu naught times of I. So magnetic field B is equal to mu naught I divided by 2 pi R. This is a magnetic field due to the current carrying wire of infinite length using Ampere's law. Just imagine if I is equal to 1 ampere, R is equal to 1 meter, what happens? B value is B is equal to mu naught into 1 ampere divided by 2 into pi into R is equal to 1 meter. So B is equal to mu naught, you know where, 4 pi into 10 power minus 7 into 1 divided by 2 pi. So 2 pi cancel, this is 2. So magnetic field B is equal to 2 into 10 power minus 7 Tesla. So 2 into 10 power minus 7 Tesla. This is wire. Almost B earth is equal to 10 power minus 5 Tesla. So compare these two, which is equal to the ratio value is almost equal to 100 times, which means B wire is less than 100 times of B earth. Magnetic field of wire is lesser than the 100 times of magnetic field of the earth. Is a very important one, just comparison. So the magnetic field due to the current carrying wire of infinite length using Ampere law is equal to B is equal to mu naught I divided by 2 pi R Tesla.